In section 2, we're going to perform some automatic water masking and buffering. So one of the main issues, as I said, so we have these mangrove ecosystems. They live in the coastal zone, and it's really important to try to mask out your water. Sometimes you might have grasses, you might have mud flats, you might have things that might confuse your classification, and we really want to remove those as much as possible. And this is the lovely result of the automatic water masking. Now you have to be careful. There are some places where it might not work as well. And what you need to do is the automatic water mask works by you place a point. If there's in the script, we already have a geographic location, but you can move a point to basically a place where you have water and land. You put that point there, and then the magic Otsu method, which I stole from Gennady, is it provides some statistics in that area, and then we'll show you. It does a little histogram here. It makes I believe it's a water index, a normalized difference water index, and it has this histogram here. Now, if I does it around a window of the point, now let's just imagine it was in this window here. What you're going to have is a lot of pixels, as you see here, in the really low range, and these are probably areas of water that has a very, very low vegetation index, or this different wetness index, and then you'll have a lot more points that have this higher value of that index, and those are the land areas. And so the pixels are distributed in this water and land. And the Otsu method, honestly, I don't know how it works. It's magic, but it finds a threshold for you, and in this case, works like a charm. And so the threshold in this case is minus 0.19, and you'll see that's kind of after that big hump in the histogram. So I really like this, and this is a really essential step to mapping mangroves. And also there's another great chapter in this book on benthic habitat mapping that I contributed to. The water mask is really important when you want to map submerged ecosystems like coral reefs. So use that canny edge detector and Otsu thresholding whenever you can. After the water masking, then what we do is we invert the water mask, and then we select only land. And then in this case, I say that the mangroves are limited to areas that are at an elevation of less than 40 meters. And that'll change, of course, on the geography, but that seems to be the case around here. Mangroves do not live upland. They live along waterways and on the coastline, and so they're rarely found above these elevations. You can change that parameter in the script to make it whatever you like. We use the NASA DEM, the digital elevation model from NASA, to do that. And then what we do is we use a map of existing mangroves. In this case, it's a collection that's available in Google Earth Engine from Geary from 2000. It's a map of a mangrove mistent, and so it's a nice baseline, I find. And what I do is I take that image collection and I clip it, and I buffer it. And why do we buffer it? Because maybe since 2000, we might have lost mangrove, so the mangrove area might have shrunk. But in a lot of places, what we've been finding is the mangroves actually expand. This can be as a result of climate change, changed water regimes, restoration, a number of different things. So what I do is I buffer the area around my baseline map, which is, let's say, older than the time I'm mapping now. And then that allows me to essentially potentially map any gain or extension of mangroves. And you'll see actually the chapter after mine, I think section A3.2 talks about mangrove change in Guinea, and you'll see those areas of gain in Guinea. So it's really important to do this buffering. And once again, you can also change the parameters of the buffer. I use 1 kilometer. You can make it more or less. All depends on your study area. Okay. Before I get to section 3, I believe there's a question in the chat you can address. So in pixels covered by clouds, you use Sentinel-2 to include those areas in your models, or the combination of Sentinel-2 and this little button is like, and a single model means that pixels are lost because of cloud cover. Okay, yeah. So the issue with so I really like the CPAL image compositing approach. What you can do is you can choose different time ranges of your data to fill in the clouds. Okay, we're lucky. This is kind of a lucky area. We have a nice, we can get a nice cloud-free mosaic by combining a whole year of imagery. Some places, if you're mapping, I've mapped areas, for example, in East Africa in the 90s. Imagery was much, let's say, scarcer with Landsat. And what you can do is you would take more years of data to make that cloud-free mosaic. So what you do is you have more yeah, you basically expand your range of dates. Another thing though that CPAL does is you can use, and it's also in any of the compositing available in the chapters here, is that you can choose a cloud threshold. What I do in cloudy areas is I put that cloud threshold very, very high, and it selects, all the super cloudy images. But if there's one good pixel, it'll use that one good pixel. So, so basically, the most important step in this approach is in fact creating that mosaic and creating that composite and making sure it has no clouds. If it has clouds, they can be masked like in CPAL, and then you can either replace them with another sensor or another image or another date, or you can make another map from another year and combine them that way. So I hope that there's no pixels lost because of clouds or shadows or haze. Okay, so if that answers the question, I will continue on to section 3, unless there are any other questions. If not, we'll keep going. So section 3 is where it gets fun. Now what we're doing is creating training data and running and evaluating a random forest classification. Now, what's important here, and I think is the real highlight of the method, is that I'm trying to minimize the user interaction, user error, and I'm really just using an existing map to take my training data and run my models. Now, most places already have some sort of baseline map, or you can see, like I said, you can see mangroves pretty well in imagery, so you can put in your own training data. But I really like the automatic training approach because you can really play with some parameters. And what I do is I take this image, this data from Geary, let's say, and I run an erosion and a dilation. So I don't know if you can tell, but all the edges are gray here. There's all these edges that are gray. These are kind of edge mangroves, and then all the green is core. Core mangroves are really the center of the mangroves. And why are we doing this? Why? Because when you have a mangrove ecosystem, it's highly unlikely that the middle of the mangrove will be deforested. Why? Because if you've ever been to a mangrove, it's one of the most miserable places on earth. There's like 2 feet or 10 feet of mud. It's absolutely impenetrable. So if someone is going to cut down mangrove trees, they're not going to go to the center of this area. They're going to stick to the edges. And that's what we find in a lot of these mangrove systems over time. People munch or eat at the edges. And so when I'm dilating and eroding the Geary layer, I'm really searching for these inside areas, deep inside the mangrove, and I'm going to select my mangrove training data from these areas in green, and these are what I call core areas. And that's run by, you define a kernel, and then you do a dilation, and there are a number of iterations. Now, I think I threw a joker in the script where I put a really high number of iterations. There's not a lot of training data. I will show you how to change that to make the outcome look more like this. So we do that for the mangrove areas, but we also do it for the non-mangrove areas, right? So I remember I ran my buffer, so I'm going to have areas of non-mangrove in my mask. And to be sure that these areas are not mangrove, I'm going to pick non-forest that's far from this edge of mangrove and non-mangrove, right? So my non-mangrove areas are going to be selected from the reds, and my mangrove areas are going to be selected from the greens. This is the layer called training areas, right? Okay, once again, I'll show you how to adjust those kernels and basically create your own training map. You can, of course, at any time add your own polygons. You can draw your own polygons, maybe add some more training data from another area, fix your classification. You can really amend it as you go, either by adding points or polygons, converting them to rasters and adding them to your training areas. So then we run the classification. And one of the things I love about this Google Earth Engine approach with the Smile Random Forest is that now we have a lot of bands. We have about 73 bands that we added in a nanosecond, right, to our composites. We have all these different statistics. We have all these different indices, all right, ratios and all this kind of stuff. So all that is added to my image stock. I have 73 bands, and this graph will output the variable importance. So how much a band contributes to classification. And you can download this as a CSV. Sometimes you can't see all the names of the bands. So you can download it as a CSV, and you can look at which, like these really low, maybe these low bands that aren't really having much importance. You can remove them. You can just not add them to your stack or take them out, and then see how it improves your classification. So I believe that is the end of this section. And I will answer any other questions. So yes, somebody Asks, is this approach able to distinguish mangroves from other low-lying veg that are separated by water quality or the like, i.e. transition to bald cypress along gradients? Yes, so precisely. So one of the things I found, for example, in Mozambique, where I did a lot of mangrove mapping, there were these kind of terra firma forests. So they're kind of alongside the mangroves. They're on terra firma, meaning they're not really have their feet in the water or their roots in the water. And the indices that we derive here help discern those. And now, even if you look at them in high resolution Google Earth, or if you look at them in optical imagery, they look green. They look like they're on the coast. You might think they're mangroves, but they're not. So that's why it's true that this other veg are they're not going to be mangroves if they're not really in the water. Now, bald cypress, I don't know if bald cypress are tropical species, so I don't know if they'll be really mixed with mangroves. But like I said, these other types of coastal forests, you'll see the difference. Now, there is one warning. There are some, they're called non-mangrove associated species, and there are some species that like live with mangroves, particularly in East Africa, that are not technically mangroves, but they're, same thing, they have their roots in the water. Those ones might be more difficult to discern, but generally, this approach will let you tell the difference between these different types of forests. Exactly. So, and Fiona has a great question. If you've already have the known areas of mangroves, what is the purpose of your classification? So, yes, if you have a map from the same year you're interested in, why I want a classification. Most of the times, the maps, mangrove maps that exist are old, or they're out of date, or maybe they were made with Landsat, and now you want to make a nice Sentinel-2 10-meter resolution data. Maybe you want to even run this on Planet and make a 5-meter resolution mangrove map. So it's really helping you fine-tune the temporal resolution or the temporal accuracy of your data, and update the map with something else. Or you can also go back in time. You could do the same thing. You can take a newer map and then go back in time with an older map. So really, this is about adjusting the spatial resolution based on a new sensor. It's also about improving the maps. I've seen a lot of horrible visually interpreted maps that were hand drawn. Those are terrible, hard to reproduce. And so when we have a digitally produced mangrove map, we can also produce repeated classifications over time and actually see change. This is also a great way to stratify some of the work we're doing with FAO, the Food and Agriculture Organization of the United Nations. We need to look at changes in different forest types, and sometimes we need a really good stratification. So right now in Kenya, for example, we have maps. They're too old. We need an updated map to be able to stratify our landscape and determine where we're going to visually interpret or assess calibration or validation data. So it's really important to know where these mangroves are. And finally, it's always really important to have an updated mangrove map. As I said previously, if you want to look at gain, if you want to look at loss, mangroves are extremely dynamic. So it's a good idea to have either annual or biannual maps of mangroves. And Stacy, sorry. Oh, so you're talking about the bald cypress in Florida. Yes, exactly. So there are mangroves in southern Florida. Yeah, I'd have to look at what the spectral reflectance of bald cypress are. I think they're not as densely populated as the mangrove species, but mangroves they usually have a very they're very green leaves. I believe the bald cypress have more of a needle leaf, so that could be something that would help determine them. And I believe, yeah, cypresses might not be as evergreen as or have the same like chlorophyll reflectance in leaves as mangrove species. Feel free to follow up with me, Stacy. I did do some mapping a long time ago in southern Florida. Great. Any other questions? If no, I will continue and discuss the bonus material. The bonus material, there's an extra section in the script, which has a lot more indices. So in the script, as it was, I just had I think a simple NDVI or something, but I've compiled a bunch of indices, and I even have even more now. And once again, a link to that database. But now you can see how you can really add just any number of databases, any number of indices you want, and you can also derive stuff out of Sentinel-1 or whatever you want. But I shared a link to a database of indices, so you could put tons and tons and tons. But it's always a good idea the advantage of using Sentinel-2 has these red edge bands. Near R on the red edge are some nice, these 3 different red edge bands are really good at this discerning vegetation. And then, and then the square bands are really good also for wetness, and so on. So yeah, you can add a ton of different stuff. Okay. So where are we? So let's, shall we just jump right in? And I will load the script. Make my screen a bit bigger. So as you know, yes, when you start, you have this mysterious blank window. And I'm going to go down to the script for mangroves. And let's start with the first checkpoint, which is, so we have an AOI here. It's already coded. We have this point with the land and water. It's already hard coded, but you can make it yourself. And we're going to load, oh yeah, that's another thing with, I forgot to mention, with Sentinel-1, it's cloud independent, it's active radar. Things can look kind of different in the wet and dry season. So I think it's neat to separate them to really get the maximum amount of annual information. And what's also great is that CPAL does a lot of these statistics. So what I can do is I took I don't know, I found out when the dry season was like 3 months or something. I took the 3 months of the Sentinel-1 data, and then it comes up with all these statistics, means, maximum, averages, standard deviation. And those statistics I think are really good to kind of differentiate what's happening. So just 1 second while I put this. Okay. You know how cats are, they want to go in and out, in and out. Okay. Yeah, so these are these, let's just load these. So these are these images that I pulled out of CPAL. I got my AOI and I have my Sentinel-2 data. Look at that, that's really nice. Now, of course, we are lucky. We're working in a really easy area of the world where the mangroves really do stick out. So everything loads pretty nicely here. Once again, if you want to import your own image, you would just need to change the AOI and change this point. I don't even know where this point is. Why don't we add it? Let's just add it. Map.add layer point. We can run that again. We can just see where that point is. If it loads up, I don't know. Oh, it's a vector. We'll see. Okay. There it is. Okay, so that point was on land, and if you wanted to make it a feature thing, you could also do that here, change that. One of the things I told you, so in the S1 data looks kind of fun. I mean, it looks okay. It looks kind of purple. But one thing I like to do is I kind of play around sometimes with these indices, and you'll see all these the different bands that come out of CPAL. This is all cool stuff. This is like some really neat ratios and things like that. So I find this stuff kind of gives me a nice information of what's happening. So let's just do, I don't know. There it is. So I just did a nice little stretch here that shows you how these mangroves really, really stick out. Okay, so that's where we are with loading the imagery. Everything looks good. Everything overlaps, right? I got my AOI. I think we can move on to the next step. Does anyone have any other questions? Then we will keep going. So checkpoint A, really easy. Okay, now we're going to go to checkpoint B. So we got the same AOI, same stuff. So now, yeah, we have an index, right? So we've taken this Sentinel-2, we've done a normalized difference index, really simple, and I added a ratio of the SWIR and NIR. And then what we got to do is we got to add this all together. So we're stacking the S2 with the NDVI with that ratio, and then we're adding the wet and the dry season S1. Okay. I might have added S2 twice, actually. Oops. So there we go. And now we'll have a list of those bands. We'll do it later. Sorry, that's the checkpoint. But yeah, so here's my nice water mask. So I don't know. Nobody really knows what's happening here. We can even just click the arrow and do it. We know what, so this is all automatic stuff. that's happening. With the water mask, all automatic. And let's see what's going on. So it's all, I don't know, you could just ignore all this. You'll see that the threshold is automatically selected. And yeah, and then let's look at some of the layers that are here. So we have some of these edges. I don't know, it's the edge. Oh, look at that edge of the water and land. Then we have a land mask. Okay. Oh yeah. And once again, this is the reference mangrove data set from 2000, but you can add any any image you want. In this case, it's an image collection. Here's some image collections that you can just mosaic, but you can also add a polygon or anything you want. Here's the buffer distance. You can buffer the area around the mangroves. You can just look at that. Right, so we have an area outside just in case there's any change in the mangroves. And that's basically it. I got my nice land mask. Look at that. Yeah, I got, this is actually water up there. And yeah, my lovely water mask. I think it works pretty nice. Any other questions? So this is what, sorry, this is what it should look like now. Let's keep going. And now we're going to get the training data and we're going to basically the classification. Now there's one thing I wanted to show you what I was talking about before. Let's just unclick these guys. If we look at our training areas, and you'll see that in this example, there's actually very few core areas and very few non-forest areas, but we can change that. Let's just go find our kernel here. Kernel. My kernel's radius of 3, I like it, but instead of 3 iterations, I'm going to put 1. And I'm going to do the same thing. Oops. I'm going to do the same thing down here. Do 1. And then what you're going to see now is you're going to see a lot more non-forest and mangrove areas. And that was actually one of the questions in the chapter was I think looking at how you can change that those training areas. And so if you look at it now, you look at it, it looks like the example I showed in the talk. And this is better. You'll have a lot more sampling areas, and that's how it'll go. Oh yeah, and here's where you can determine how many points you want to sample in each category. You just pick 2000, but you can change that. And then it's going to choose automatically within the strata. It's going to choose 2000 samples of class 1, 2000 samples of class 2. And it's going to do the same thing for a validation data. And then we're going to run 2 classifications on the first on the image of the training data, then on the validation, and it's going to give me some nice information over here. So let's go on the right and see what's happening. This is my training bands. And did I accidentally put in? I might have actually put in S2 twice. I'll change that code. Jeff, I'll have to fix that. And then, and this is kind of nice. I mean, this is kind of expected with mangroves, but basically what we're doing is like we're putting training data in classes, we're taking them out, we're classifying, we're resubstituting, and you can see that there's very, in my 2000 points, there's very, very few misclassified points, maybe like 2 points are misclassified as something else. Or 10 here. It's so, it's just like a kind of accuracy on the diagonal. You want a lot of your points here. So my training accuracy is very, very high at 99%, which is kind of expected. And then what I like here is the variable importance. And if you click here, you can download the CSV and you can look at it, but you can basically see like what is the least interesting band is probably this one. I don't know, it's NCDC. It's a coefficient of variation from Sentinel-1. And you can take that out and you could run the classification again and see and see what it looks like. Oh, Twee has a question on why is the formula of the SWIR near divided by near plus 0.1. So the formula of the ratio, yes, when you do a band ratio, you divide the SWIR by the near. Why did I add 0.1 to the denominator? That's to avoid any divisions by 0. And we don't want to have any, if you have your band near IR equal to 0 anywhere, which is possible, you would have an error. So I just add that 0.1 to kind of prevent that error. That's a good idea to do in your band ratios. Great question. So that's basically it. So then I have my mangrove classification, which this is in the bands. This is always going to work. Very nice. And I can see my, it's really nice. Now, a lot of places, if you want to follow the forest definition. So forests are, they're composed of multiple trees, not just a single tree. We have what's called a minimum mapping unit or a minimum area. And generally, most forests are measured either on a hectare level or a half hectare level. And so here I just said, okay, how many pixels are basically a pixel is kept when it has 25 neighbors. That's 250 by 250. That's the size of connected neighbors I want. So that basically removes the salt and pepper effect, which you might have. And so that's where you can also change the parameter. You can make it 9, you can make it 10, you can make whatever you want. And then you have a slightly cleaner classification. So that concludes the demo of this chapter. I will quickly show you the supplemental information. These are these extra indices. Right, we've got NDVI, we've got MGWI, all these kind of things. And oh yes, where would I add those? I would add those then, I believe in so if I did this, just copy these. Exactly. What I would do is I would take this and I would replace that in that, I believe it's in B. Exactly. So right here, I would put in all those other indices. And then I would replace that stacking, the stacking one, which, where is that anyway? The one where I saw that had that error. Oh, it's right here. So instead of that data stack, I would basically replace this whole area here. So from line 49, you can replace with supplemental info. Great. And there's your map. There's your mangrove map. I'll take any more questions. I wish you the best. Feel free to get in touch with me if you have any other questions. This is a pretty general standard approach. I mean, there's a lot of ways it can be improved. And of course, you'll run into different challenges in different areas, but nothing's impossible. So thanks for listening.